Kubernetes itself, you could argue, was not really designed for AI ML workloads, but it's starting. People are running on there. And so our goal is to try and make it, honestly, hopefully as simple as possible for people to run these. And we all kind of agree on similar APIs because we're all solving similar problems. So.
Hi, welcome to the G-Research Open Source Software Outreach Podcast, the GR-OSS OUT Podcast. I'm your host, Jay Faulkner, and I'm here today actually sort of a reunification of sorts. When I first started working at GR-OSS, 4 years ago-ish at this point, Kevin was one of the people who was already there at GR-OSS working on Armada and making things go. So this is actually pretty exciting, getting a chance to catch up with him a little bit. So Kevin, welcome to the podcast. Why don't you, tell us a little bit of what you've been up to and what like communities that people might have met you in.
Yeah. Hi, everyone. My name's Kevin. I'm under GitHub. My GitHub handle is Hannon92. Pretty much right after G-Research, I did a lot of batch workload scheduling under Armada and thinking about multi-cluster scheduling. And while I was working there, I started talking with a lot of folks in trying to improve Kubernetes batch workloads. And in there, I was actually contributing to a working group batch in Kubernetes, focusing on stuff like queue and JobSet. And pretty much since then, I've been working on trying to improve Kubernetes for batch workloads. Now it seems like everyone is all about AI, so you can call it AI workloads, but essentially it's all one and the same. A lot of my experience at G-Research has really kind of influenced how I think about people scheduling jobs, and honestly, sometimes how some people want more their jobs scheduled over others, and trying to think about how to make sure everyone can get their work done fairly.
So I'm going to be honest with you. I think you're underselling yourself a little bit because what our listeners may not know is that Kevin actually won the Kubernetes Contributor Award for a lot of his work on node test. It said SIG node test infra, which sounds like one of those decoder ring statements that someone in the CNCF community is going, oh yeah, the SIG node test infra. But talk to me a little bit about that. What was so special about that it got that level of recognition, which is really something to be quite proud of?
Well, really, a lot of it has been that in my company I work at now, we are responsible for a lot of the Kubernetes features going into upstream. And a lot of times I may not be involved in all these features. Like I may not be developing a single feature, but I might be overall looking at the health of all the stuff going into the release. And a lot of times it's been helping triage, like if somebody has a feature and it's breaking our test infrastructure, how can we, figure out what the problem is and how can we roll that out in a safer way so that it doesn't block people from trying out these features or impact other things. And so a lot of what that award was on was just helping, or basically be willing to dive into features that I may not have been involved in, but help kind of triage the issue and maybe try to loop in the right people. I actually think Jay, one of the first things I remember from Jay was always pushing for, when you're getting involved in an open source project, getting involved in the CI. and I guess you call it contributing to the commons, is always kind of an approach I kind of take where, our goal is to have a healthy product, and we're all kind of, we want that most of all. So that's something that I always actually take from you, Jay.
Well, I appreciate that a lot because, there's a reason when we talk about the commons that is usually talked about, in the sense of that cliche of the tragedy of a commons, where if you've got something that's a common community resource that there's not a specific person or entity in charge of maintaining, it tends to sort of rot over time. And that's a pattern we've seen in OpenStack. I've seen almost every, repository we've ever gone in. There's always something with the CI, and there's always this what's the word for it? It's almost like a fog of war, right? Like if you're a new contributor working on a project, you don't have any context as to, do these tests pass 100% of the time? Is this one of these things where we've got 70% of them pass and the maintainers know that. And having someone to help drive you through that is incredibly useful. And honestly, I think it reflects really positively on CNCF and the Kubernetes community that they recognize that as well, because that is, part of that invisible work of getting people onboarded and things. So is there anything systematic there that has been or could be done? Like, is it if someone's starting out today and they have that CI failure, are there going to be better resources for them, or is it still pretty much a mentorship model?
Yeah, we're always trying to improve maybe the labeling of our jobs and make it smarter so that like a lot of times what we find are the side effects of a feature breaks something completely unrelated. And so one of the ideas is to have like in Kubernetes, we have a lot of the concept of feature gates, and all our features start in like a level of alpha, beta, and GA. And we might have like a lane where we turn on all our alpha features and try and figure out like if I turn this feature on, which is not quite ready, does it break something else? And so one focus has been trying to get more like a better signal in all these jobs. Other things we've been doing is trying to trim down, like Kubernetes supports so many different operating systems, and the big one in containers world is cgroups v1 and v2. And another thing I worked on last year was just trying to slowly phase out cgroups v1 from like basically the container community, because like it's one of these things like people don't care too much about it, so no one really feels the need to move off of it unless it's really impacting them. So some of it's just like trimming down old OSs so we have less to maintain, and other times trying to deprecate old features that we know are actually hard to maintain from a test infra perspective. And that might be done as like a more forceful deprecation. But all those things really help, I think, for the health of an open source project.
So the feature gating, it seems like that might have a positive effect on willingness to merge changes. Because I know in OpenStack, sometimes when you get a code review, as a code reviewer, I can be a little bit afraid because, if I approve your change and it modifies the API and it's wrong, we owe people that compatibility. But it sounds like maybe y'all have a little bit more flexibility there when something's in the early stages to mold it even after it's out of the cage at first.
Yeah, I think we're getting better. I think that I don't know if it's a problem with all like open source projects, but I think in Kubernetes, we have a very strong like waterfall mentality at times. Like for our Kubernetes enhancement proposal or KEPs is all focused on, we define all of what we want to do in the beginning, and then the hope is that it doesn't change too much over time, which it always does. And what I found, probably what I'll talk about later, is features that have a long history are always the hardest things to get promoted, because like they might go through 5 or 6 different authors in the span of 6 to 8 years, and then nobody remembers the original design of it. But you have to but there's like reasons why people wanted it in the first place, and then you might be the unfortunate soul that gets to take it over. And yeah, it's like those things are probably very common. But yeah, I think like what we're trying to do in the Kubernetes community, especially with all these AI efforts, is to maybe be more willing to roll out like experimental changes through feature gates, or maybe accept that we won't solve everything from the get-go, but we can, like, we're not saying like we have to solve this right now. We're saying we can iterate on it. And I think that's always important, because you'll never get all the use cases that everyone has from open source. And honestly, you'll probably you'll hear a use case like after your feature has been GA'd and someone's like, oh, this is completely broken for me. And then, they'll file a GitHub issue that's like a bug and be like, you need to completely redesign this feature. And we're like, well, this not quite, but we can think about your use case better.
It is, I think, difficult for an incredibly large distributed open source project to be opinionated. And that's really what we're talking about, right? About like defining this is the way you've got to use this feature, not this other way. and sort of dictating a little bit to people what their environment has to look like if they want this benefit. And so that's always fun. But I know you said something about y'all are sort of trying to pull out some of the features that might be a little bit heavier to maintain, trying to maybe streamline, make a little more aerodynamic for maintenance. Is that informed at all by the recent issues with issues isn't quite the right word, the recent retirement of the Ingress Nginx controller, which is a really popular use in most Kubernetes environments, and it's just sort of going away because of maintainer burnout issues, difficulty in maintenance and stuff like that. Is that sort of something that's common in that community that's being fought back? Like how does that relate to sort of the topics we've already talked about making it more maintainable?
Yeah, that's something I probably am not experienced enough to comment on. My area, that's more on the networking side, which hasn't been necessarily something I've spent a lot of effort on. In our case, from what I've worked into, it's more like cgroups v1 is a good example where the kernel introduced cgroups v2 like 10 years ago. And slowly the ecosystem has been switching. And we got to the point where systemd actually effectively from newer OSs just said, we're no longer going to support this. And by default, we won't actually start your node. If you're with cgroups v1, you have to opt out. And so that was like, we were like, okay, like it's getting harder to, run our tests on CentOS 8 now. Like we're having to kind of, like actually make a much harder effort to get these things running because like these things are end of life and they're the only ones that fully support this. So that's more like my area of the maintenance. The Nginx one is a hot topic, but yeah, I'm sorry, I can't really answer that one.
Oh no, that's perfectly fine. And I mean, I think I get that a lot too. I actually had an email yesterday from someone asking, like, I'm an OpenStack expert and asking me lots of questions, and half of my answers were redirects to the mailing list because it is such a large space, the cloud space in general, OpenStack, Kubernetes, we're not even talking about the whole CNCF landscape. Just Kubernetes is so large that it's hard for a single person to know all about it. The cgroups v1 to v2 stuff sounds really interesting though, and I think that that is one of the more difficult things to get resources for in open source, is kind of that migrating from a thing that works to a thing that will also work. And all of the benefits of that were felt by others. Like I'm assuming you're not getting that many more features out of cgroups v2. And the main reason I'm saying that is that I'm pretty familiar with cgroups. I'm assuming it's V1 because no one ever called it V2. So the numbers usually come later. And I've not heard about a lot of innovation there, but maybe I'm wrong. Is there some benefit that's coming with that, or is it just a back-end swap?
There are some benefits. Some of the stuff has been smarter ohm killers, has been something like we've been kind of thinking about. Like Meta actually does a lot of work in the kernel around.
So can we hit a timeout and explain to folks, because I know we might have some people with different backgrounds. By ohm killer, you're talking about the out of memory killer, right?
Yeah.
And so can you maybe just give us a sentence or two about what that is for folks who might not be familiar?
Yeah, so I guess there's an idea of basically you have in cgroups, you have a memory enforcement at that level where if your container exceeds the memory, the ohm killer will step in and kill it, but then you also will kill the pod. Then you also have the case where let's say you're on a node and all your jobs are running and it turns out you're coming to a limit of your node's memory that the kernel's uncomfortable with. The ohm killer steps in and will start killing those processes to protect the node's health. And yeah, some of the stuff has been like one of the reasons why we really are pushing for cgroups v2 is a lot of the enhancements of the memory controller for cgroups has gotten a lot more work done in cgroups v2. And there are also newer features coming out. And sometimes we're getting to the point where there are features in Kubernetes, like especially around swap. And there's another one called pressure stall information that we cannot support with cgroups v1. And then we have to kind of decide that we're essentially feature complete for cgroups v1 and then start doing that with v2. It's another one of those like subtle ones that you don't know too much about.
You say subtle, but honestly, like my background's as a sysadmin. I've gotten paged many a times at night from the old school kernel OOM stuff before those hooks existed. And the previous behavior was it was whatever processed asked for the RAM that the kernel couldn't provide. And out of memory is not just physical RAM. That's your physical RAM, your swap, everything. You're like, that process that's like, give me another byte of RAM is the one that's going to get OOM killed. And so it was basically a lottery back in the day where, if you had someone running a script on a database server to gather stats and they maybe didn't do a good job of keeping it from just eating the memory on the box, you better cross your fingers and hope and, rub your lucky charm or whatever that it's the script that's actually at fault that requests that block of memory and not your MySQL server. Because if you got a MySQL server, you might get woken up at 2 a.m. and have to, fix a broken database. Not so fun. So the OOM killer stuff's really exciting. And it's nice to know that that's getting baked into Kubernetes a little better.
Yeah, I mean, that's like one of the bigger things with cgroups v2 is it actually provides, there's a feature in the kernel called pressure stall information, which is more like it's better metrics for like pressure rather than the ohm killer, which you're explaining is what we effectively have in Kubernetes, where like once we get to a certain point, we're like, we just have to kill something. And then it's never great and no one ever really wants their stuff to get killed. But yeah.
So I'm trying to put the pressure stall stuff like in a box that I understand a little bit. And I always think to top, or like if you run top, or especially one of the newer, fancier ones, I prefer btop, but there's a bunch of them. It'll show you actually a letter that indicates why a process might not be doing work right now, why it's stalled. If it's IO, if it's CPU contention, network contention, is that the sort of information that you get with cgroups v2 that you used to not get?
Yeah, exactly. So
that is so cool.
Yeah, they do it for CPU, memory, and IO now. So I think there's HTOP is the one I have that has like some of this information that kind of shows the pressure stall information, which like Kubernetes is leveraging the Linux kernel, and we have to kind of keep up to date with the later changes, but also support existing people and support long-lived Linux distributions.
Yeah, it's definitely it gets complicated pretty quick when you got to support old stuff too. But staying on Kubernetes, one of the things that I saw was there was a pretty big proposal by you and a couple of your colleagues around job sets in Kubernetes. Can you maybe give me an overview, or our listeners as to what job sets are, and maybe don't be afraid to zoom out a little bit, because while you and I worked on batch scheduling a little bit, I don't think most folks in the world have.
Yeah, so how would I describe it? Basically, the idea for Kubernetes has never been great at batch workloads and AI, ML, or high performance computing workloads. And a lot of times what we have found...
What is a batch workload?
To me, it's a job that like runs to completion, and the goal is that the job should finish within like a reasonable time. The reasonable time is up to whoever decides that. But with Kubernetes in general, Kubernetes supports services and batch jobs. And a service to me is like a web server that's always running. And when the process fails, it gets restarted. And so, that's kind of like a lot of the crux of Kubernetes is to keep, web servers running and database servers, and those things should always be running. Now, a batch job is separate in the sense that I will run this job and I know that it'll probably finish within a few days or a few weeks. And then it's okay that if it succeeds with, exit code 0, I know everything is good. If it has exit code other than 0, something bad happened. And that's kind of the idea for batch jobs. Things are blurring with the AI mania that's going on now. But one thing that's interesting that is what's driving a lot of this interest is AI serving is now it's a service that is always running that uses an accelerator like a GPU. And that, I think, is changing a lot of people's mindset around like what a batch workload is. Because in my eyes, it used to be I run a job and that job uses GPUs. And that's where a lot of the working group batch that I worked on, like we focused on. And then JobSet, one of the ideas there, sorry, I'll go back to that, was that for JobSet, like we have a workload where let's say maybe I have, the main use case what I'm seeing is for for an ML project in Kubernetes called Kubeflow. One of the ideas is you have a job where you're pulling a model down, and then you want to run like a PyTorch workload once the model is pulled down. And then this workload has a lot of requirements around how many pods are running in parallel. And when one of these pods fails, I want the entire workload to end. And I don't want to kind of get in this restarting loop where like one process is failing while the other ones are expecting that process to be up. And then things are kind of, I'm hogging this important resource that everybody wants. That's kind of at a high level, what JobSet we were trying to provide was a higher level API for people to submit training jobs that has stuff like failure policies built in, or like when certain parts of my job succeed, maybe I want to consider my job overall successful. And so that was a big thing. Yeah, I actually started working, well, I was reviewing it at G Research, and then I've always been kind of contributing to it. And I guess probably 2 years ago now, I became a maintainer of that project. And so a lot of what we're trying to do is just make it easier to run training workloads on Kubernetes, and it's getting some adoption, which is fun.
Scary. The
Yeah.
more users you have, the scarier your life gets as a maintainer, generally speaking. I mean, we talked about it a little bit before, kind of leaned on it here, but like you were an engineer here at G Research Open Source Software, working in kind of our open source policy office, really on a lot of these same topics, right? Like Armada, batch scheduling, those sort of things. And now you're working at kind of a more of a product-based company, one that's, less aligned with a single user and more aligned with the open source ecosystem as a whole. Does that change your approach at all as an open source developer?
It's a really good question. What I find, at the scale of working at a large open source company is that you really get to see like all these use cases and all these bugs that are coming in, and you have to kind of prioritize which ones you can actually fix. Like, part of what's exciting about working in Kubernetes is a lot of people are using it, but I can't necessarily fix everything that people come up to us. And then like we will get loads of users using this in their environment. Some of them don't like the behavior of Kubernetes and they want us to change it. And we can't really do that because like it would break a million other people. I think the hardest is deciding what's worth our time to focus on and really dive deep into. And I am still struggling on that one. I think at G Research, one of the nice things there was it was very focused on batch jobs and training. And like, we didn't get quite as much like, oh, there's this very different use case that I never thought of that now we have to support also, which is kind of what's fun about, working at a vendor-based company.
Well, the interesting thing, it's sort of interesting because we've talked about in the past how like our lives have some weird parallels. We both were living in Blacksburg at about the same time, some of that stuff. And similarly, it's like I see some of the parallels between OpenStack and like something like Kubernetes. And at one point in time, OpenStack was the hot commodity. You would go to the OpenStack summits and there would be 10,000 people. There would be booths everywhere. There would be everyone with a hot new OpenStack thing, similar to if you go to KubeCon today. But with that also came a lot more crazy asks. It came with a lot more people who wanted OpenStack because it was OpenStack and not because they had thought deeply about their use cases and that it was the right thing. So it sounds to me like maybe you get a little bit of that over in Kubernetes land as well, where, people maybe choose to use Kubernetes before they even think about whether or not it's the right fit for how they want to use their system.
Yeah, no, there's always, the complexity of Kubernetes is a pretty heavy software for a lot of people. And I would say the big use case is AI is one where a lot of times some people will question whether or not it's really a great platform for that. And then we will see a lot of cases where we're trying to fit maybe something that was never, Kubernetes itself, you could argue, was not really designed for AI ML workloads, but it's starting, people are running on there. And so our goal is to try and make it, honestly, hopefully as simple as possible for people to run these. And we all kind of agree on similar APIs because we're all solving similar problems. So,
yeah.
But
well, there's a lot of overlap in them, right? Like, and the places where they differ is always weird and fun to me, right? Like, I'm ironic, I'm the bare metal guy, but there's an entire group that's all about AI, that's all about sort of the hardware side of this batch work, that, you know, they want to carve a GPU up into 12 pieces because they have students in a classroom who maybe don't need to do real work, but need access to dedicated hardware to prove it. So it's always interesting to see how a lot of the problems are kind of the same, but different.
Yeah, that's, you speak to like my heart there. Cause yeah, that's a big thing that, you know, I started my career as a scientific researcher in computational science. And basically, I was always focused on how to run jobs on a large set of machines. And then I kind of view there's a big area, high performance computing, where people have been doing this for a long time. And now AI, ML, whatever, is kind of bridging into that again. And so a lot of times I've been trying to work with people in that community, trying to think about, you know, they all kind of run into the same problems, like, how do you run these large jobs across multiple machines and keep them running? And how do you do stuff like checkpointing, like saving the state of your jobs? Because at the end of the day, you have a large data center, you're going to have nodes failing, and you have to account for that. And I think what I see is a lot of that kind of problems is what's happening in Kubernetes. Like, how do we account for the fact that GPUs are failing all the time? And how
that's
do we,
like the perpetual cloud problem, right? Like, that's always the hardest thing about a local cloud is, like, you know, if you're calling AWS or GCP, they have just stacks of spare servers in the back. And if one fails, they're happily just point you at another one and you'll keep going. But if you've got a 200 servers in your data center and one of them, the GPU goes bad, that's a bit of a different emergency that maybe you might approach differently than a hyperscaler would.
Yeah, and that's, I think, one of my favorite things is working in a hybrid cloud company is I get to experience like people that are not like, you know what, I can just create a new machine. like I don't care why this is failing. It's just a bad machine. I'll let it be someone else's problem. And I find, like, you know, it is nice working with the bare metal folks where they're like, no, I need this disk attached. Like, this is the disk I have.
Yeah, it's like, I know it's a bad machine. That's the reason I want you to help me do it. That's
yeah. So yeah, we'll get things like memory, like, oh, like I can always just create a machine with larger memory. But then, you know, when you talk to bare metal, they're like, I want to get the most bang out of bucks from this machine and not just like create a new one.
Well, like, you start talking to bare metal people in the hallway. If you were at the hallway track in Paris, the number one topic among people who were running big hardware is the more RAM you put into a physical machine, the longer it takes to boot. We have people reporting that they have machines that first boot took 1.5 hours plus for memory training and 30 minutes to boot every time after that. So wow. It's the problems you get at that scale, they flow all the way through the thing. I'm happy to have had a chance to learn a little bit more about the stuff at the top of the stack. You know, I always joke to people, ironically, we get the servers racked and then give them to the smart people who make them go burr. I'm happy to have had a chance to talk to one of those smart people who help them go burr today. But, you know, we don't always have a straight shot from A to B for stuff like that. You know, we were just talking, it's not clean. You get those gross moments, and that's true for the software development as much as it is for hardware. So can you maybe tell me a story about a time when something happened to you, like a gross moment, you know, a discouraging thing or something, and what you did to turn it around, and, you know, how you kind of came out of it at the end?
My favorite project, or that really represents this, was making Kubernetes aware of swap. You know, swap is a pretty popular construct in Linux. It by default was never supported in Kubernetes. Like, we actually would have a flag in kubelet. You couldn't start a node on a swap enabled machine. And for years that's
sharp.
Yeah, like, it was just not something that Kubernetes ever supported. And so we slowly kind of rolled out some ideas of how to get that added. And this was Kubernetes 1.25. So probably 10, 15 releases ago now, we first added the support for it, but it kind of stalled in alpha and then went through a couple rounds of people. Then I started taking it over and I was like, okay, I'll try to get this to beta. And then we kind of ran into all these problems where, like, what we would find is that even though we had this field that we said was not supported and no one should ever use it, we found that our entire CI was actually setting this because it was it was easy to get a node that had swap enabled and to turn it off. So then I originally was like, you know what, we'll just say like this is actually a cgroup c1 v2 problem where for swap, I'm going to disable swap on cgroups v1 because this was for a technical reason, we weren't supporting that anymore. And then I just like basically like took out like a bunch of jobs that were failing, and I'm like, why are these jobs failing? And then I just like started searching our code base, and I was seeing like our default template was like starting with this flag that I thought was just for developers running on a desktop machine, but it turned out it was like half our CI was running with swap enabled and then just like disabling this flag. So then I had to think a little bit about how to phase this out without breaking a bunch of people that were using what we said was not for production, but people were ended up using it for production anyway, which is kind of...
I usually don't stop for questions in the middle of the gross out story, but I am curious, just a technical detail here. I'm assuming you mean that flag was saying, yeah, allow us to run with swap, skipping that hard fail check. And I'm assuming it was in your CI jobs because having enough RAM to actually run CI is impossible since our AI brethren have bought it all.
Yeah, I mean, pretty much it was that. And also, yeah, that was kind of the issue is, yeah. And then over time, it was just thinking about how to roll this out in a way that doesn't break all these like use cases that we didn't really think about, especially I hinted on this one earlier, but it was like taking this feature that's been around for a long time and the people that first created it they're no longer working on these projects, and you kind of have to reverse engineer archaeology, the Git tree, the Git history to figure out why the design was done this way and then try and change that. And it was exciting to see that after probably a couple rounds of going back and forth, we did get this to GA. Unfortunately, like there was a lot of back and forth about what I like to think of, waterfall or agile practices. Like, can we get out the most perfect thing we ever want, or can we get something out because we know like what we have works, but we can improve it down the road? And so I think we finally won out on getting something out that we've been working on for a while and accepting that we know there's going to be some follow-ups that we need to do, and maybe there'll be a better way to do this, and then we can kind of improve that. And so the open source politics is the thing that I did not quite appreciate until now that I've been around the block now. It's amazing how opinionated people can be.
People say politics, and I think when we say politics, we're anchored to government pretty strongly, and people have strong opinions about that. But really, politics is just like a science of helping set policies. Like a healthy, large open source project is always going to have policies. And, I'll tell you, it's pretty brave to lower the scope of something to get it released, to make it done. That's the thing it's a difficult decision to make. But usually leads to a positive thing. So that's really good. There are lessons that other people can learn following in those footsteps. Like the thing I always think about is that code archaeology, right? Like if you've never had the experience of having to dig through someone else's code, figure out what it does, figure out why they wrote it the way they did, the shape they did. That's really difficult work. And there's no real magic trick to it. You just have to do it. You got to figure it out. Well, maybe a Gen AI might be a little bit of a magic trick, but the trick will be you when you miss the one thing that it misinterpreted about the code. So just be careful. But that was a great story. I love to hear it. Is there anything that you might want to point people at? Do you have a blog or, a kept up for review that you'd really like to point folks out or something?
The area that I'm most excited about now is a kind of initiative in Kubernetes called workload aware scheduling, where our goal is to try and bring stuff like gang scheduling into Kubernetes core. And so that's always been a long time coming. And that's probably my favorite thing I've been involving myself in now, is trying to think about how do we get to a world where all these things are more supported easier, so people can get this on all their clusters and not just, special vendors.
So workload aware scheduling, are you talking about like, I need these things to all run on the same physical machine or in the same physical rack, or?
Exactly. Yeah.
Okay.
They call it topology aware scheduling is becoming a big one, where people want to run jobs on the same rack, and VLink and everything. So
it's a fun problem. We have it. We share it together. So if you hit a headache or you just want to bounce ideas off the wall at someone, feel free to reach out. That sort of stuff is interesting. But I do want to say a quick thank you for Kevin for being on our show here today. It's always nice to talk and catch up with someone. And I mean, we were talking a little bit before the show about how, like, it's not necessarily a loss for Gross when someone moves on to another position if they're staying in the open source community. That's a seed that's planted. And, I'm glad that Kevin is sprouting into the award-winning Kubernetes contributor tree of wonderment. So I appreciate that a lot. And thanks to G Research for giving us the time to the venue here. If you are in the London, UK area and you want to go see events about ML, you want to apply for a job, something like that, head over to gresearch.com and look it up. They've got all sorts of stuff going on. But for now, for today, on behalf of myself, our producer, Ben, and Kevin here, I'd like to say goodbye and thanks for participating. This has been the Gross Outreach Podcast, the Gross Out Podcast. Have a good one, everyone.